So here's a demo of, it turns out the misnamed WorldSim. There is a WorldSim in here. It's not a WorldSim anymore. It's a decision-making tool. It's a reasoning tool, but it's structured to overcome a problem. And the problem is that models are trained in information. And in order to train them, we need sufficient information, a volume of information, and it needs to be in a format that we can use to train a model. There are lots of domains where that works: coding, math, astrophysics, the law. There's lots of structured data there. There are other domains, like, for example, corporate negotiations, where we know the start point and we know the result, but we don't know exactly what happened in between because we don't have recordings of all the information. We don't have people's decision-making written down. So we not only do not have today, but I don't believe we will ever have a sufficient amount of information to train a model specifically to be a negotiator. So how can we overcome that? Because these are high-value domains. And the approach that I'm trying is to give the model a set of heuristics, a set of rules of thumb or rules or laws to follow to work in that specific domain. And if we can do that, we can then essentially give it the best practice of how to approach this particular problem and ask it to start solving it. So I'm going to drop in this situation here, which we'll talk about for a second. And essentially it outlines that one company is trying to acquire the other. And it's got certain conditions about the share price each group wants and some other limitations. But the first thing that's happening here is it goes to a router. And what the router is set to do is say, what kind of situation is this? So you can see heuristic negotiation. So right away, it's identified correctly. This is a negotiation. And because it's a negotiation, it is now pulling those rules for negotiations into the prompt to the model. So what it does, it takes the scenario summary, which has additional conditions and restraints on it, parameters. It takes an additional set of rules, which are specific to negotiations, packages all that together, and then we're going to send it to another model. And this is where the WorldSim comes in. So we're not just sending this to a general LLM, we're sending it to a world simulation. So it's been asked to simulate the world at this point as at December 2023, because we know there's training data to that point, to simulate what the world looks like at that stage, which adds an additional level of detail. And you can see it's created this sort of simulation. And the point is that's meant to recreate the real world. So if there's something that the model wants to do in a scenario that's impossible in the real world or highly implausible, it should reject that. It should also reject anything that doesn't meet the goals. It should also reject anything that doesn't meet some of the rule conditions. And so as it iterates through this, it's set the simulation, it's run the simulation, and then it's given a summary of the acquisition pack. So what's interesting here from my perspective is each time I run this, the answers are slightly different. So there's a big consistency issue that I need to overcome, because this output is not wrong. It's not dramatically different from the other results, but it is a little bit different. The structure is different, the rationale is different, and so we need to work on the consistency point. But what it has done is taken a fairly abstract concept of company A wants to acquire company B. There are certain conditions. What does that look like? It's then applied a set of rules. It's then taken those rules, run a simulation, and laid that scenario, those requirements, and those rules on top of that, and then come up with, in this case, what it has given me as the optimal acquisition path. So as a proof of concept of this approach to problem solving, I'm quite excited about this. It's taken a week or so to figure out how to do this. I'm not sure if this is the final approach, because I had a different approach a week ago. But I think that this combination of a simulated world to give a sort of realism to the problem solving and a set of rules, if we can establish a set of rules for a domain, holds a great deal of promise for these specific, very highly technical, but low, poorly documented domains that are still require solutions.